facts, 701,498 hectares of forest have been lost this year. Hectares are a little bit bigger than a football field. Nearly 1 million hectares of desert were created this year. 8,643 species have gone extinct, and 609,000 tons of toxic chemicals have been released in some capacity this year alone. So there's hope. Starts with this class, right? Some small degree. 382 million megawatts of energy used worldwide today. Only 29 million of that is from renewable sources, which is less than 10%, I will say. It's around 7%. But at any given time, 36 billion megawatts of energy from the sun are striking the earth at the same time. So trying to harness that number is really one of the big keys to a more sustainable, lower emissions future. Some sustainable examples: 845 megawatt wind farm. This is in Arlington, Oregon. It's about 30 square miles. One of the issues with renewable energy right now is the amount of land that it actually takes to generate large-scale solar sites or large-scale wind turbine sites in particular. There's also some concerns about bird migrations and birds getting caught up in the wind turbines themselves. So that's why you'll see some environmental groups lobbying against large-scale energy production of any kind, whether it be coal or renewable on some level. So there is a movement, we'll talk about it, moving to distributed energy. Who knows what distributed energy generation is? So this would be an example of concentrated energy, right? You have a bunch of wind turbines in one location generating electricity just like a coal-fired power plant far away and then pushing it into the city. What if you had a solar panel on every roof that's already in a disturbed area? That's kind of what we've been talking about, sustainable land use, not disturbing parts of the Mojave National Preserve or really windy parts of Oregon that might just be virgin Greenland right now, right? But actually distributing that energy to places that already are disturbed, over parking lots and over parking garages and on rooftops. So that's kind of one of the debates we'll talk about a little bit. Largest operational wind farm on the planet, projected to provide 2 billion kilowatts per year. It also supply approximately 235,000 households, employs 400 construction workers and 35 full-time workers. That's another thing. It's not a huge job generator. There's something there, but not enough to get us necessarily out of the recession. Distributed energy might be a better solution. 1,300 megawatt solar installations outside of LA, 10,500 acres of land, largest operational solar array on the planet, projected to provide 3.7 billion kilowatts per year, able to supply 845,000 households. So you have to temper all these things we're going to be talking about as a trade-off. You know, if you have low flow fixtures, that might be a trade-off in terms of occupant comfort. You have light sensors that go up and down hallways. You won't have the lights on all the time, and people might think they're closed or something like that. So there's always a customer trade-off, or a social trade-off, or environmental trade-off. In this case, you might get solar renewable energy that's not polluting the environment directly. You're taking up 10,500 acres of land. Right? You have a question?
As running for the last two examples, with both supplying 800,000 households, which time is it a billion?
Well, that's going to be based off your annual generation. Remember a few slides ago we said the average American household uses 12,000 kilowatts per year. So that's kind of like its average. So here's some actual sustainable buildings. This one's from Lebanon, the Charles Holster Student Center, 104,000 square feet. Some of its sustainable features, which you'll become familiar with a lot of these as we go through the course. Cited to maintain existing trees. So when you have trees around, you have a small microclimate. If you ever notice walking around campus, much cooler within that quad area than it is when you're walking from the parking lot or walking off of Maryland into that area. So just think about those little microclimates. If you ever go to the Springs Preserve, that's a really good example of a microclimate. They have a lot of desert adaptive plants that retain moisture, provide shade, and keep the temperatures down overall. So exploitation of microclimates is a good example used here. They're near the ocean, so they're trying to capture those ocean breezes to keep stagnant air away. Overall use of natural ventilation. One of the common principles used is just cross ventilation. If you just have one window, you're not going to have much of an effect. If you ever just open one window in your car, you usually want to do the one that's the opposite, diagonal across from you, right? The same idea in a house or an apartment or in a commercial building like this. And also recognizing the fact that heat rises, trying to provide that ventilation out the top of your building, kind of create an actual swoop in, cool air coming in or cool air coming in, and hot air going out the top. Proper orientation. What do I mean by proper orientation? Ideas? Right. So, when I was looking for a house, or when you're looking for a house, you don't want your house. This is your big giant back window, right? The sun's doing this, right? Let's say this is east. Picture's reversed right now for you guys. So all day long, those rays are coming in to this window and heating up your house. You want that side to be the most shaded. You want to have northern-facing exposure so that you get benefit of daylight without getting the detrimental effects of those southern rays coming in and creating kind of that hot effect. So if you're renting an apartment or buying a house, try to pick a lot where the orientation of the building isn't detrimental to your overall heat gain through those windows. You have solar just coming through the windows. You experience it in your car. So I'm trying to make these small connections so you guys can kind of visualize the commercial and residential impacts. But we've all experienced how hot your car can get just by sun coming into those windows. Same thing happens in your house. What happens? Your air conditioning bill goes up, your electricity bill goes up, you end up spending more money on electricity, turning on more coal-fired power plants, and we have detrimental social, environmental, and overall economic impact. Right? Terry Thomas office building. This is in Seattle. 40,500 square feet. Some sustainable features. This is a LEED Platinum commercial interiors and a LEED Gold core and shell building. Who knows what a core and shell is? Core and shell. Just think of the idea. Like a nut has a shell around it, right? It's the skin of the building. It's the outside of the building. So, you're building an office building. One of the first projects I worked on in conjunction with my team, I worked on a pretty minor. I started out, I didn't really explain this last class, but started out at Caesars here in town. I worked at multiple campus projects back in Florida, a lot of LEED projects. I've probably been working on LEED projects for about a decade and in different historic preservation capacities and office buildings and academic buildings. I moved out here working on the really large scale structures that were going on 2005, 2006, which maybe some of you were around to see that, the big times, let's say. I started out at Caesars Palace, a large expansion, $1.3 billion expansion, a couple of LEED projects there. And they were also doing the Mulaski building, which is downtown. If you guys are familiar at all, it's a blue glass building right here at Union Station, Central Park area. So that was a LEED Gold core and shell. So, say this is the skyscraper portion of, if you know the building at all, it's got like this parking garage down here. This is the tower part with all the glass, right? So the core and shell would just be this actual glass, and then within here, on each level, what do I draw on here? What's in the internal workings of a typical office building? The elevator core, the common systems that operate the entire building run through that core. So the mechanical, electrical, plumbing systems, and the actual shell and the floors of the building itself. So it's the core, the actual elevator core that comes all the way through, and the shell that kind of wraps the whole thing, right? So the core and shell can be certified as a LEED Platinum, which is the highest ranking you can get. And then once you have tenants start moving in, each one of their tenant improvements, because usually tenants will only rent, floor 5 or a quarter of floor 4 or whatever it may be. You'll have 50 tenants within an office building, and so you'll be able to certify them as they develop those little pieces of the property. So while other pieces of the property might be vacant, you'll be able to certify the ones that are actually being occupied. So that's why there's two rating systems for the core and shell, the outside scan, which is always done early in the project, and then once you get tenants, the tenant improvements or commercial interiors, which is the CI, can take place. Does that make sense?
Okay.
Yeah.
How is it that the improvement is right in the corner shell, or is that example that's the
So the Platinum has different rating systems. So within the actual Platinum designation, there's different rating systems for each of the things that are prudent to that system itself. So they have different criteria. So for the core and shell, that's measuring overall building usage, overall materials usage. For the tenant improvement, that's looking at tenant finishes. So where the core and shell might have had to use really structural steel and glass and things that maybe weren't as recyclable or located regionally, the tenant improvement itself, the CI, could have used materials that maybe were more local, reused and recycled. So it just depends on what's actually being installed and implemented on the inside and outside.
They're rated differently,
Right.
right?
I mean, it all goes certified silver, gold, platinum. That's how all the rating systems work. But they have different criteria to get there. The commercial interiors doesn't talk at all about locating your site because the site's already there. So it's just different credits, different points, and ultimately different materials. Core and shell is a lot of your hard structural materials, glass, steel, concrete, and then once you get into the inside, it's carpet, finishes, gypsum board, wall covering, those kind of things. So there can be a little bit of a difference. And we don't know what the point differential was. It might be really close. It depends also how committed your client is who's actually renting that space. They might really want to go for it and pay a lot more and upgrade. And the building owner might have just paid for simple glass or simple mechanical systems or whatever it may be. So you're able to achieve different types. So some of the benefits: enhanced occupant health, daylighting. You can see a lot of glass on this building. But what you can also see is they have little light shelves as well. So at the worst part of the day, the hottest part of the day, it's actually blocking some of that sunlight from penetrating too far into the building and increasing that heat load, right? Located next to transit, which you can see, using mass transit, it's more sustainable than taking your own individual automobile on the highway. Natural and cultural connection. So it's located across the street from a park, there's museums, and other cultural interests in the area. So remember, it's not just about the environment, but that quality of life and overall triple bottom line as well. So community revitalization, community engagement, kind of building up dollars in the community, and having people down in this area. Rocks Library Center, it's in New York City, 178,000 square feet. Sustainable features: 90% of debris was recycled from the existing demolition and then throughout construction. We'll go over some of those strategies once we move more into construction waste. 20% energy savings. Like we said before, energy can be saved in all different manners through all different disciplines. It's material selection, MEP, mechanical, electrical, plumbing, designations, and then equipment selection, how the building's sited, where is that sun coming from, those types of things. 80% of wood FSC certified. Anyone know what FSC is? It's Forest Stewardship Council. So what they do is they're a third party. Remember we talked about the importance of third parties telling you that something's green or sustainable. Otherwise, there's no real rigor to it. There's no real backing. You can say that you took all these classes at UNLV, but if you don't have that degree, but the third party, which is UNLV, no one's really going to care, right? So it's kind of the same thing. It's a credential. It's a rating that these wood companies get. And basically, this is a sustainable forestry initiative where they're not clear-cutting forests. They're selecting prime wood locations, allowing the forest to regenerate before coming back and cutting again, and creating a more sustainable forest culture and forest industry overall. It also uses very low formaldehyde. Formaldehyde is a known carcinogen that occurs naturally in the built environment, but it's also used highly in construction materials as a glue. In high concentrations, it can give people different forms of cancer. You guys remember those Katrina trailers? Everyone was getting nosebleeds and like brain aneurysms and different brain cancers. So high level of formaldehyde within each one of those trailers because they were made very cheaply and very quickly of all these different resins, right? So it all comes full circle. Nationals Ballpark in Washington, D.C., 178,000 square feet. 83% of the debris was recycled here. 15% overall energy savings. 35% less water use.